then we're going to transition into our second segment, which is public safety. And so in this segment, we have three companies coming to speak with us. The first is Eirene.Ai, which is an early fire detection using a camera agnostic computer vision model. The second is Precise and Sapfonte, and it is counterfeit and substandard drug detection using machine learning. And then finally, ZeroEyes, which is armed threat detection and response through computer vision. And we also have a little bit of a content notice as well for one of the presentations in the public safety section. It focuses on the detection and deterrence of active armed threats in the public. And so we're mindful and acknowledge that this content might not be suitable for some participants. And so making everyone aware to use your own discretion. And so with that, I'll hand it over to Eirene.Ai.
And let's do this. Hello, my name is Suk Singh. I am the Chief Operating Officer for Eirene.Ai. Our goal is to maximize the utility of existing camera infrastructure across the United States to look for signs of fire with the computer vision model that we've built over the last year. So why did we build this? Really, there's three big reasons. First is to protect our natural resources. Secondly, to protect our first responders. And most importantly, to protect our communities across the United States. Each of the fires that you see here have a through line. Each put people and property in peril. Each required hundreds to thousands of firefighters to contain them. And most importantly, all three could have been caught sooner with the camera infrastructure that was already in place around them. Our civil servants that respond to these fires and plan the response, they're fantastic at planning and response. 100% of all fires in the United States have been contained, as a fire chief once jokingly told me. But we aren't built to process thousands of camera streams and look for anomalies. It's simply not what the human brain does best. That's really where Eirene comes in. So this is essentially how Eirene.Ai works. We connect to your infrastructure. Regardless of what kind of camera it is, we go ahead and integrate it and pipe your camera streams into our model. Once the model is calibrated, which can take a few minutes, up to an hour, we go ahead and start looking for signs of fire in smoke or fire in every single frame. If we find something, your team is alerted. They can get any form of notification that you'd like, and also they can view it live on the dashboard. Then they can do what they do best, which is to coordinate the rapid response to that early detection. A lot of our competitors want to replace the billions of dollars of infrastructure that state and federal agencies have invested in, and we simply can't wait for that, and have thus engineered a solution that makes the most of the existing investment as it is. Here is a demo of Eirene in action. I'll go ahead and put it in full screen. Our cloud model is immediately scalable and processes at the same rate, whether it's one camera or 1,000 cameras. It can also get the GPS location of the fire once we've triangulated. It's built to keep humans in the loop. Experienced civil servants get the alert and utilize the dashboard to confirm the detection and to activate the rapid response. Ultimately, we know how important their role is in this response, and thus we've built it around a lot of the feedback that we've received from dispatch, as well as different fire service agencies here in California. Sorry, there we go, let's continue. Okay, on to the technology specs. So really our technology is accurate, adaptable, and can integrate with your existing dashboard. As I've mentioned already, we're camera agnostic, so regardless of the stream, we'll be able to work with it. And we've worked with some pretty low quality streams. Through my work at UC Berkeley, as well as with Marin County Fire Service, I've had the pleasure of working with leaders in the space to inform our approach. Our AI team has utilized thousands of hours of footage to train our model and has used the best available technology and has developed unique algorithms in order to capture signs of smoke and fire and not confuse them with something else. I've had the privilege of working with fire chiefs and line personnel to collect data, collect feedback, and continue to iterate our approach as well as the dashboard that they utilize. There are some additional features that we're working on, such as edge deployment, super processing, which is just taking low res to high res, low resolution streams to high resolution, and removing fog and weather, which can sometimes confound certain models. But I'm happy to discuss this in more detail offline. We're grateful for the billions of dollars that cities and federal agencies have invested in the ultimate early fire detection system. At least that's how we see the massive amount of camera infrastructure that exists in cities as well as in wildland across the US. We look forward to working together and supercharging this infrastructure to protect our natural resources, first responders, and most importantly, our communities. Great. So to really wrap things up, these are our upcoming deployments. At this point, our model is quite stable. As I mentioned, we're working on our edge deployment. And so in Q4 of this year, we'll be deploying at an electric car factory, as well as at a private land developer that's developing in the WUI, which is the wildland urban interface. It's like where the greatest amount of development is happening today in the United States. And so it's becoming more and more important to protect it. You would be very surprised by the number of fires that start as people are actually developing and building in these areas. And from pretty much the inception of our company, we've worked directly with National Security Innovation Network and Department of Defense, and have actually done a demo at Camp Roberts in partnership with SoCal Tech Bridge, and we'll be doing a permanent deployment at a base in Q4 of this year. Lastly, as I mentioned, I've spent over 2 years working with Marin Fire Service, and we'll also be deploying on their hillside cameras that watch some of their most high-risk areas in Q1 of next year. Our company is only about a year old, so last year at this time, I was a runner-up at a National Security Innovation Network hackathon. This kicked off the inception of our company, and really right away we began building, we raised funding, and today we're preparing to deploy. I'm grateful to be a finalist here at the AI Challenge and look forward to leveraging this massive opportunity that you've afforded us to continue to accelerate our growth and protect the things that matter most, which is property and people. Thank you so much for your time. Here's my contact. Please feel free to call or text me, shoot me an email, and there is our website. I look forward to the Q&A section.
Thank you. Thank you very much. And reminder for folks, great reminder, if you have any questions, please drop them into the chat and we will get to them. So then next up, we have Precise Sapfonte, which will be presenting a counterfeit and substandard drug detection platform through machine learning.
Well, good afternoon, everyone. My name is Abdullah Yusuf. I work as a product manager for Precise and Sapfonte. I want to encourage everyone to scan that QR code to learn more about our innovation. For the past few years, my team and I have been hard at work on a solution that we think will save lives by removing counterfeit drugs from the market at an unprecedented scale using machine learning. And I'm excited to share it with you today. Before we get into the solution, though, I think it's important to start by understanding the scope of the falsified drug epidemic in the world and the solutions in the market today trying to address it, shown in that chart in the bottom. Not many people realize that approximately 15% of all drugs on the market are counterfeit. We constantly hear about the impact of falsified birth control, the opioid epidemic, the loss of life from drugs laced with fentanyl. And these drugs constantly target the most vulnerable communities, both here in the US and abroad in developing countries. Estimates put the economic cost of this problem at $200 billion, but we believe this is a gross understatement because the network effects caused by the loss of human life aren't accounted for. There are many solutions in the market that provide different ways to address this problem, but they all suffer from the same bottleneck. They can't scale because they need SMEs, subject matter experts, to either run the chemical testing or analyze the results and ultimately extract actionable outcomes. So it turns into a resource problem. And that's the problem we're trying to address by bringing in machine learning to efficiently extract actionable outcomes without the need for subject matter experts on the ground. Machine learning has not traditionally been used in this space because most traditional algorithms require counterfeit samples to train the machine learning models, and these samples are constantly evolving and really hard to get a hold of. By utilizing a new novel one-class classification approach available through our enterprise SaaS platform, our solution only requires authentic samples to train the models, and this allows us to solve one of the biggest challenges in this field. And our data backs up our solution. Our lab results shown here publicly for the first time prove that our solution is incredibly accurate and can differentiate between brands of the same drug, but is not so sensitive that it gets confused by batch-to-batch variants of the same brands. And our process is even simpler. You take images of the authentic samples via our device, upload them to train models in our Eirene.Ai SaaS platform, and then deploy those models and test samples in the field using our device and get instant results. And we plan on making this machine learning platform available for other applications as well by the end of the year. So let's see this process in action. So here you see the web application for our platform. Here, what I'm going to do is I've already uploaded authentic samples, and I'm going to show you how you would start a new training instance to train a machine learning model, just so you get a feel for how easy it is. I give the instance a name, a descriptor, I choose the model that I want to use, and I'm going to select the samples that I want to use to train this model. So I'm just going to select all of them in this case. I'm going to go next. I'm not going to execute this because it takes a while. Instead, we're going to use a model that is already deployed to a box here. You see my colleague Nathan putting in an authentic Tylenol pill. There's a Tylenol model that has been deployed on the device. And he's going to use his mobile application for this device to trigger the test. He's going to pick the model that he wants to use. He's going to put in data for what he thinks this pill is, whether it's authentic or not. And this just helps train that model continuously. And he's just clicks that button and immediately it begins testing. You see the machine power up. There are cameras and 4 light sources in the machine: UV, infrared, visual, and imprint. And there you see that similar result at the top of the screen. Now he's going to take out the authentic sample and he's instead going to pull in a counterfeit sample of Tylenol that has been modified. So he puts in that pill and you're going to see him repeat that exact same very simple process, right? He's just going to click that button, he's going to select the pill, he's going to put in what he thinks it is. He's on the field in this example, so he's going to say that he thinks this is an authentic sample, and the machine will tell him what it thinks it is and give him immediate actionable outcomes right away. You'll see that pop up in just a second, and you'll see the counterfeit or different screen show up at the top of the screen there. And that's the demonstration, just to show you how simple this is. I want to conclude this presentation just by encouraging all of you to scan that QR code, go to our website, learn more about us. We've got so many exciting announcements coming soon that we would love to share with you. We're releasing our lab data in full. We have an academic publication on the way, and we're also releasing new products, which we're going to be sharing free trials for, and we would love to get feedback, would love to work with all of you. And yeah, just want to give a big thank you to all of you for your time and to GSA for having us. And I look forward to the rest of the presentations. Thank you so much.
Thank you, Abdullah. And so then to close out this section, we have ZeroEyes presenting on armed threat detection and response through computer vision. And just a gentle reminder that this is on active armed threats in public.
All right. Hey, good afternoon, everyone. My name is JT Wilkins. I'm the Senior Vice President of Government Solutions here at ZeroEyes. Really excited to be presenting to you today. Just want to do a quick screen share check, make sure everybody can see my screen.
Yeah, looks good.
All right, awesome. We'll jump right in here. So at our core, ZeroEyes is a computer vision company that focuses on identifying visible weapons off of existing security cameras to mitigate and stop active shootings in any environment. We are the only video analytic company that's on the market today that has the Department of Homeland Security Safety Act designation, which ultimately offloads liability from a designated act of terrorism onto the Department of Homeland Security. We went through 2.5 years of testing, looking underneath the hood of our system and algorithm to receive that designation. So our story, we were founded in 2018 following the Parkland shooting in Florida. Our co-founders, our team are made up of former special operators and intelligence personnel. We saw a need in the community to stop these problems from continuing to happen and solve some of the gun crime that we've seen throughout the United States and proliferate. So we brought together key technologists, saw the problem set, leveraged military background, and built out this company in order to solve this problem through a simple solution of integrating AI into your existing security camera architecture. So in terms of the company, like I said, we were founded in 2018. We have about 102 full-time employees. We're headquartered out of Philadelphia. As I mentioned, we're Safety Act designated. We currently have, we're deployed in 26 states, 19 in K through 12 districts. We're working with some big name Fortune 50, Fortune 100 companies to ultimately reduce the risk of active shootings inside of any of those environments. And then ultimately, we're leveraging some of the effort and some of the background that we've had in the military to bring that to all levels of the federal government and state and local governments. So ultimately, how does it work, right? We're looking at this. We pull and take your existing security cameras. We pull the RTSP stream off of those cameras and run our algorithm through that RTSP stream. It's looking for visible firearms only. We don't do facial detection. We don't get into people characterization. Ultimately, we're looking at looking for a visible firearm and a visible firearm only. There's some reasons behind that, and I'll get into that in the next slide. So in the case of us identifying an object only, identifying that weapon only, we don't have any PII or FERPA concerns that come along with our software. We're looking for an object. Our algorithm is asking one question as it scans video frames: is there a gun in this image or not? And if there is, we go through our process. So from a visual description standpoint, we send a team, whether our managed service, our 24/7 operations center, or in the case of federal government with closed networks, out to a security operations center, an alert to verify. That alert comes with a keyframe image. So that's an image of the weapon in the shooter, a timestamp, which is the time elapsed since that weapon was seen underneath the camera, and the geolocation based on where that camera is located at. All of that comes in within milliseconds of that alert going through the platform. On the human verification side, the ZeroEyes team will verify an alert in 1 to 3 seconds and have that back out to first responders. We can guarantee to our customers that they will never receive a false positive from ZeroEyes through this human verification process. Ultimately, those alerts that come through our platform will get sent back out into a number of different alerting devices. It's an open architecture file type. It's a JSON, so it can go out to any device that is acceptable or can accept that type of file. So we'll push out the public safety information management tools, access control devices, video management systems, mass notification platforms. We have our own mobile application, so it'll come directly to your phone, and then a user interface that can be accessed via a whitelisted web page. So we can really get this information out to everybody very, very quickly to help mitigate the effects of that problem set. So in terms of looking at the active shooter or armed threat problem set, when looking at the last 50 years of data, we found that in 85% of mass shootings, a weapon was presented for anywhere between 2 and 30 minutes before the first shot was fired. That's ultimately why ZeroEyes. There's a lot of other technology out there focusing on the acoustic detection, the gunshot detection that requires the gun to be fired. We're able to identify that weapon ahead of time, send an alert directly to the security operations or law enforcement, and get ahead of the problem before that first shot is ever fired. We call that being left of bang. So we're able to get law enforcement back on scene with anywhere between 2 and 6 minutes. The national law enforcement response time is 12 minutes. When we look at other previous shootings in the United States, typically that weapon is out for between that 2 and 30 minute timeline with an average of 7 minutes. We're able to get law enforcement before that first shot is ever fired if you look at the average. So I want to walk through and start a quick video here. This is our platform. So from a privacy concern, our software integrates directly with your security cameras. However, we are unable to look at that live video. So we're not able to ever tap into your live video in your facility. Once a weapon is detected underneath of that camera stream, we're going to start getting a bunch of alerts that push into our platform. At that point, we're able to give it a unique identifier. We know exactly what client it's located at, and we know exactly where that camera is. It's going to take a human verified alert to go through here and look at the platform. So as you can see in the image here, that still image pops up. We're able to verify, yes, in fact, that's a weapon, and then we're able to dispatch that out. So as we're kind of going through here, our human verified team is going to go ahead and look at this, dispatch these alerts, send those direct out to law enforcement or the Security Operations Center, and ultimately dispatch that to through our dispatch page. What we're looking at here is our client side. This is what you would receive on your end. In this case, we're looking at that bouncing icon there. That's telling us the last known location of the shooter based on the camera's location of where that's at and where that camera is looking at. The other pin drops there represent cameras that are on our platform that either have or have not received an alert. We're able to cycle back through here to get a better understanding and have better situational awareness as this situation on goes, or as that shooter moves throughout a facility, providing a breadcrumb trail in real-time situational back to law enforcement. I'm going to go ahead and pause there and stop. I really appreciate the opportunity to present today here at the GSA Applied AI Challenge. I'll drop my email address if anybody has any specific questions into the chat, and we'll look forward to answering any questions during the Q&A session. Thank you.
Thank you, JT from ZeroEyes. So now we'll transition into about 10 minutes of question and answer. Our first question is going to be directed toward Eirene.Ai, which focused on early fire detection. And the question is, can you allow firefighters to see your video feeds simultaneously?
Yes. So most firefighters today are equipped with either a smartphone or an iPad, and so they can pull up Eirene directly on either of those devices, and they can also receive alerts if their signal doesn't allow for them to get a constant video stream. They can go ahead and get screenshots as well as the GPS coordinates for where we've estimated the fire might be.
Thank you. So then a question for Precise Sapfonte. Great effort to keep medicine safe. Are there efforts underway to allow testing non-solid pharmaceuticals like vaccines and insulin?
Yeah, so we do have a plan to add support to that. Our machine and our sort of system theoretically already supports it. We're just at that stage where we're testing and verifying what those accuracy levels are for those types of drugs.
Thank you.
Mm-hmm.
And so then this question is for ZeroEyes, focused on armed threat detection and response. It might be impossible to implement, but what about proactive steps with potential shooters before they become active?
Yeah, so it's a hard problem to solve, right? At the end of the day, these things happen in minutes and seconds. What we're trying to do is provide an early warning detection to provide time back to first responders and law enforcement. We have been deployed in locations that have had an active shooting event in those facilities. And from the law enforcement providers that have spoken to us on our technology, they've said if they had 10 seconds given back to them, they knew exactly where that shooter was in a facility during that response stage, they would have been able to save lives. And so that's a really powerful statement to make. And so for us, ZeroEyes is specifically focused on once that weapon is brandished, we're able to see that underneath a visible camera. We can get that alert out as quickly as possible to save time and save lives.
Thank you. So I have a general question for each of our panelists. So this category is focused around public safety. We heard from Lynn Parker about the importance of public trust. And so I think that's tantamount in this category in particular. How do you see your technologies enhancing public trust in the US government?
Should I go first?
Yeah.
Okay. That's a fantastic question. I completely agree that public trust is at the forefront of really applying a lot of these computer vision or AI technologies. As far as how it would enhance how the public sees the federal government, I think it shows that, at least for our specific solution, it shows that there's a reason for all of these devices to be out here. It's not just for it to be something that we see as a retrospective to evaluate how something might have happened. It's actually like, it gives a reason to have those CCTV and hillside cameras. And it utilizes computer vision and AI in the way that I think, it really shines in partnership with people. So, our model will go ahead and find the fire for you, but then ultimately the individuals that respond are the fire service and the individuals that the public trust the most. So I think as far as enhancing public trust, I would just say that, it's showing that you're better leveraging your existing infrastructure and that you're using it to do something that our existing fire service can't. You're really lending them a hand, and I don't think anyone in the public would disagree with something to support and enhance the job that our first responders do.
Thank you.
I guess I'll go next. Yeah, I would just add, like, it is a good question. And I think ultimately it comes down to what our solution helps reduce and what it addresses, right? And right now in the public, in the news, we see constant reminders of the problems people are having due to counterfeit drugs or drugs laced with certain with fentanyl or the opioid epidemic. So as this device gets deployed and as those drugs get removed from the field and removed from the hands of Americans, and also as it gets deployed internationally in developing countries, that's a lot of opportunity for the government to increase public trust by just by doing a lot of good around the world. And so ultimately, I think as we solve the problems that Americans are facing using this device, that is what will lend to increasing public trust in the government.
Yeah, so I mean, I think in general, we can't turn on the news today without seeing, a violent event that happens, right? And so I think the start point is that we're all here trying to do something about the violence that we have in the United States, or the public safety applications and issues that we have in the United States. So I think that's number one. AI to do something for good. Number two is when we're looking at public trust applications, and we start getting into the concerns of bias that comes into data set development and how you can identify that, and companies that are willing to go through third-party evaluations and bring on that type of viewpoint, from an outside perspective. I think that's really important. So that way we're not introducing that, especially when you're looking at the proliferation of facial detection, behavioral characterization, other things that are out on the market. Specifically for ZeroEyes, we've done everything we can possibly do by bringing on third-party applications to really take a look at our data set to make sure that we're not introducing any additional bias. And that's where we ultimately come in with, we're looking for an object and an object alone. And if we can do something like that and save time, that's what we're looking to do, is be able to provide that back to the public as quickly as possible.
Thank you all for your thoughtful presentations and also thoughtful responses to that question.